Hello and welcome. This is part 2 of the Futures/Promises implementation on ESP8266 coding session. My name is Thomas and this is day 35 of 100 Days of Code in IoT challenge. Today we're gonna just start from the point where I finished yesterday, so let's move to the IDE straight away. One important thing to mention before I start. So because today I'm gonna start from that state of the code. This is from yesterday. So we've got this and then chaining functionality done. And without knowing how this works, you cannot really continue, right? So I strongly recommend watching the previous video if you want to get up to speed with what I'm gonna do right now. Okay? So yeah, you can find the link. You can find the link to the previous video in the description. Or also this video should be in the playlist, so that's gonna be the previous one. Cool, and now we can start. So yeah, quick reminder what this code does. Okay, we've got just a future test at the moment. There is no source, right? So we keep everything in a single file in the test file. Once I have this more or less done, I'm going to move it to a separate production code file. What this code does so far, right? So as you can see, we have a future class with two template types, right? Two generic types, T and U. And one method here that is overloaded, right? So it can take either another future or it can take a callback function. That method takes another template argument, another generic type. And this generic type is essentially the next one, is the next return type of the next future, okay? The return type of the future, maybe I remind you how this works, right? So those two generic types here, the T and U, right? The T is the input type, U is the output type, right? So think about this as an input and output, right? You know what? Maybe for the sake of simplicity, I will change this. Hang on, maybe I can actually refactor that. Rename, change all occurrences. Yeah, I think I can do that like that, right? Yeah. So this is gonna become I, and U is gonna become O, okay? Just for the sake of simplicity. So now we have I as an input type and O as an output type. And N is the next output type, okay? So because like the and then, the goal of and then method is to create another future out of the given future, right? So we've got the actual future, the given future, and the future that this method creates, right? It is like we did yesterday with the merging of two functions, right? Let me remind you this as well, okay? So let's imagine, maybe this time on futures though. So let's imagine you have one future that is I1 and O1. And then you have another future that is supposed to take O1. There is no other option, right? You can probably see it here. You see the O is the required type. You can only specify the N type, which is the return type, right? And that would be, so we have I1, O1, and O1 and O2, right? Because O1 is at the same time it is E2, right? So E2 is O1, right? So the input type of the second future is also the output type of the first future. And that's what this is what's happening in and then, right? We have the future with input type 1, output type 1, and another future which is the input type 2, that is the output type 1, and output type 2, which is N, right? So our N is O2. And that's gonna give us another future that is, this is the sum of those futures, right? It's a common future that merge those two, right? Essentially, the way this is supposed to work, at the moment, we only have a function that executes immediately on the future. So at the moment, the way this works is when you run fn method on this combined future, right? On the sum of the futures, what's gonna happen is this future, fn, is called, the result is taken, and it is given as an input argument to the second future. It is immediately called, the fn function on the second future, right? And then this result is gonna be given to us, right? So that's gonna be the result of this operation in here, okay? So yeah, let me show you. So the ultimate future that we're gonna get from here is the input 1, but output 2. You see? Again, like yesterday, this and that, they cancel each other because we're merging those, right? We're merging those two futures here, okay? And regarding this one, and then, this is very similar because like we operate on a function anyway, right? So it's either a function that we give to and then straight away, or we do it through the object, which is f2, right? Because of an f2, you have this function. Here, you just provide that function straight away, okay? So this is sort of similar. So again, we're gonna have something like I1 and O1, and we're gonna add this to a function this time, right? So this is the std function, and that function returns O2, and it takes O1, right? Or N, like it is in our case, right? And that's gonna just give us exactly the same future, right? Because the difference here is really that it doesn't have to call the method on this, right? Because this is a function straight away. So I think this explains it, and it's a good reminder for you on how this code works. But also, yeah, let's have a look how this is how this is working in action. So you see, we have this one future that takes int and returns int, and then the second future that takes the return type of the first future and just outputs some different type, which is Boolean. And what's happening in here, we've got the f1, this future, added to f2, which is that future. And what we're doing is to give the Boolean as a n type, right? So this is the O2, that's the Boolean, right? So the result of this operation is gonna be the future of int and bool, okay? The ultimate input type and the ultimate output type. But to that future, we do another addition, and this is adding a function, right? A callback function. And that callback function takes Boolean, right? It has to take Boolean. You see, it takes Boolean here, but it can return whatever it wants. And in this case, it returns const char, depending on the Boolean value, either true or false, okay? And this is essentially added further, right, to that future, and we're getting a future that takes int, but returns const char pointer, right? That's why the assertions are done on the true and false as a string values, right? Okay. So so this is for the explanation of that, okay? But yeah, as I said yesterday, this is not really a future yet, right? This is just called future, but it doesn't really work as a future. And I also said yesterday that the way we're going to approach this to make it actually behaving like a future is to go with the polling approach, right? So we will have something like a poll function in here that is gonna be constantly called until our future changes its state, okay? And state is the most important thing that we're gonna start our implementation, our, coding today, right? So let me define an enum I'm gonna call it async state. And that enum, at the moment, we just consider the positive scenarios, right? So we'll have two possible values. One is gonna be pending, and the second one is gonna be resolved. Okay, so we have pending and resolved, and that async state is gonna be returned by that function, right? So this is the function. It's like a poll function that we give to the future, and we would like this to return this async state. But yeah, we still want to keep this output type, right? It's not just the async state that we would like to return, but also the output type. So we could make a pair or something like that, or to make it even more convenient, what I can do is to define a new class. I'm gonna call it AsyncResult, and that AsyncResult is gonna take the template, type name T, and that T is going to be the type of that result. Okay, so this is really gonna be what we expect here. Okay, and let me just put it like that, right? So as you can see, we've got the AsyncResult that takes O, right? And before I implement the methods in the AsyncResult and constructor, let me show you how this is going to work here, right? From the consumer perspective, because this is important before we actually write any functionality. It is important to know how this code is going to work, like, you know, from the consumer perspective. What do we expect from this API, from this code, and how we would like this to work, right? And how I would like this to work is something like that. I think I've also mentioned it at the end of yesterday's video. Instead of returning value here, actual value, what I wanna do is to return this instead of the container, and that container will be the async result. Okay, so I imagine something like that. Instead of value times 3, I imagine something like async result, and we operate on int at the moment, so that's gonna be async result, something like that, right? Or even better, we could do something like resolve. Okay, and that would actually return the actual async result, that would create the instance of it. Okay, so you know, just, you know, for the sake of simplicity and the cleanliness of the code. Okay, so, you know, just to indicate that we resolved, this is the success, right? This is the success. The same thing would happen here. The same thing would happen here, but it wouldn't be int, that would be boolean. So, you know, just with the small steps, this is the new approach with the async result, right? But this is not really taking any advantage from that async result if we just resolve straight away, right? What's the point of doing that if we could just use maybe the callback approach, right? With the callback approach, we could do something like that, and then callback approach would turn this return value, right, either true or false, into async result, and then internally that would be handled. Okay, so yeah, so that's not the point of having the async result. It's not the point to just resolve it straight away, right? So let's think about some simplest future, something that we would like to be called at some point in time, but not immediately, not like with this resolve, right? And you know, the good example is with the timer, with the set timeout. Okay, the set timeout, how set timeout works. So if you do set timeout and you put some callback inside, you have some code in here, right? Code. And then you say 2000 milliseconds. What's gonna happen? Yeah, this code will be executed exactly after 2000 milliseconds, which is 2 seconds, right? So this is how the set timeout works. Could we turn set timeout into a future? Yes, we can do, right? Let me show you how. So with the use of the function millis, right? You probably remember millis. Millis returns the actual time in milliseconds. I think it's an epoch time, but on ESP8266 at the beginning, this is really the time from the once the device starts, it just starts the counting the time from 0, as far as I know. Okay, but you know, for us, it doesn't really matter what this value is at the given point of time. We care only about that this value being changed with the time, right? So if there is a, you know, 1 second passed, we would like this to increase, right? So if in the span of 1 second we call this millis twice, the first value and the second value should have exactly 1 second difference. Okay, so this is what we care about. And now I'm thinking about using these millis, but there is a problem with the native environment because we run this test in the native environment. You probably remember from here. You can run unit tests for ESP8266 on PlatformIO on the native environment, which is this computer, right? It's locally. And there is no millis function here. Okay, there is no millis function here, but I can write a millis function. And I have it ready. And that's how it looks like. Okay, so this is just using standard C++ library. We use the system clock now and time since epoch in milliseconds, right? So this is the millis implementation on the native environment, and now we can use millis exactly in the same way like we used with ESP8266, right? Now let me show you how this future can look like, right? So first of all, what we would like to do is to get the actual value when this test is happening, right? When it's executed. And that value, let's say it's gonna be, I'm just gonna call it maybe time or something like that. So that's unsigned long, maybe time. And we do millis. So this is gonna give us the actual time at the point of the test execution. And now, what I would like to do is, let's say, I'm gonna add 2 seconds to it, right? So adding 2 seconds to it. So now this is not a now time anymore, right? The point when the test executes, we get the actual time and we add 2000, right? We add 2000, then we capture this time here, right? In this callback function, in this future. And in the implementation, in the body of this function, I'm gonna use a simple if that is checking if the actual millis at the point of time when this future is executed is greater or equal to the captured time. And only if it is, we're returning resolve. Otherwise, we can return something like pending. And now I guess you started to notice what's the point of this whole futures operation, right? And what they can give us, right? So you see, again, going step by step, right? So at the point of executing this test, we assign a future value, right? So this is the actual time plus 2000, right? So that's gonna be 2 seconds in the future. We assign it to the time variable. Then we capture this variable, and inside this future polling function, because this is really a polling function, we check for the actual time and we compare it with the captured time. Okay, so how we would like this to work? We would like, once we start polling this future, right? Because if we do something like this is still not gonna do anything. We still need to put this future on the loop somehow, right? But you know, that's gonna be later. The only thing you need to know is, once you have this one big combined future, you need to start polling it, right? And ideally you attach it to the loop on the ESP8266, to the loop function. So this is just called continuously, right? It's just called continuously. And when this is continuously called, it is going to start from the first future. And the first future here, what it does, it checks the millis with this time plus 2 seconds, right? So let's say we start from 0. Our millis is 0. We add 2000. That's gonna give us 2000, right? And then we capture that here. And, you know, right after we start polling, so that's gonna still happen in this test, right after, before assertions, it is gonna check the millis, and at that point of time, the millis is gonna probably be 0 or 1, something very low, and that's gonna compare it with 2000, right? And because 0 is not greater or equal to 2000, this is not gonna execute, but this, right? So that returns pending. And that's gonna be the signal to the future logic in here to continue polling on this function. So that's gonna just call it again, right? On the next loop call. And then you say it's probably, the milli is gonna be 1, right? But this is still not ready, right? And that's just gonna continue on and on and on. And that's gonna be probably called 10,000s or, you know, tens thousands of times until we will have this 2000. And when we have 2000, this result is returned. And this is again the signal to the future implementation that we can move on. We can go to the next future. And then it's going to start calling or polling, right, this function. And because this function just, you know, returns the resolved result immediately, then it's gonna progress to the next one, which is this callback, and that callback also returns the result immediately. So we should have just this all done immediately. So this is the only, you know, like real future sort of function, right? That is not like immediate, but it's gonna run for some time, right? You can do it, you know, you can do it with timer like we did. This is the simplest example, and I'm just gonna work with this one for now. But also you could think about other examples, right? You could think about the example when you try to connect to Wi-Fi. When you connect to Wi-Fi, there can be like, you know, several attempts before the device actually connects. So yeah, this was really the case for, let me show you, that was the case for the Wi-Fi manager here, right? This thing, right? So we just constantly checking if the WL is connected, right? So that's another thing. However, this one was with the timeout. So we could do something like this with the timeout, right? We could just, you know, keep calling something, some method, trying to get some value for some amount of time. And if we can get it, you know, by that time, we can resolve this whole future, right? Or if we don't get it, we could reject it, right? But that's gonna be the next bit on these futures. For now, we're just thinking about the success, the positive path, right? So this is one option. I was also thinking other options, like what if you want to read some socket data, okay? So you want to read some data and you want to keep reading, and until you have, you know, the whole information, you don't want to resolve the future, the promise, right? What you can do about that? So there is a small issue with this, with that approach, right? With this more functional approach, because this doesn't really allow at the moment for changing the state, right? So you cannot have really any internal state that you can change. But there are like two workarounds for that. One workaround would be to operate on some specific object in here that can change its state. Okay, you probably need to then use a smart pointers or something, unless this is still working in the same scope. Or there is other option. You can just create a class with the operator, the function operator overload. But we get into that once we finish this whole implementation, and then we think how we can improve that, right? Because right now I would just to build the bare minimum to handle this polling sort of approach with the futures. Okay, right. So yeah, we got this done. But you see, I just looked at that from the consumer perspective, and I don't really have the code for the async result yet, right? So now it's gonna be the time to implement it. So as you can see, I think, this is the most convenient approach instead of just going, with the constructors or something, because this clearly indicates this result is resolved, right? This result is pending. And there's going to be another one rejected, but later on, right? So let me just define those static functions in here. So we have static, and this is going to return async result t, and that's going to be called pending, right? And another one is static async result t, and that's going to be resolve, right? And resolve is supposed to take an input. Okay, it's going to take an input and it's going to return the async result, right? So sort of like static way of constructing it. At the moment, I'm not really gonna go into this builder. You may remember from my previous video on the file upload from ESP8266, I've done this for the HTTP client, use the Fluent API approach with the builder. And this is my goal for the async result. But I don't really want to bother you with that pattern at the moment, so I'm just gonna create those constructors here because I can do it with the constructors. So we'll have async result, and that the default constructor that doesn't take anything is essentially gonna do the pending one, right? So if you do something like this, this returns you the pending one, but for the pending one, what I need to define is the state. Okay, so let's create this async state member. Okay, and what's gonna happen if you just use the default constructor is gonna be the state equals async state pending, right? So that's how this is gonna work. And for this one, for the resolve, this is just gonna be another constructor, but this time it will take some input, and that input also needs to be as a private member in here, right? So maybe I just call it value. So it'll be this value equals input, and this state equals async state and resolved, right? So that's gonna be approach for now. I'm gonna make those private, so it won't be possible to create the async result in any other way than just using this static methods. But I'm gonna do it later off camera, because at the moment we just want to focus on the actual logic of the futures, right? Cool. So yeah, so now this actually allows us to do that, but yeah, one more thing, because now we have no way to tell whether this particular result is pending or resolved, right? So I'm gonna add two Boolean methods to check is pending. They're just gonna check if the state is pending. And another helper method to check if it's resolved, right? So is resolved, return this state equals async state resolved. And there is one more that we need, is to retrieve the value. And I would like this to be a little bit safer. So to retrieve the value, I'm gonna use the pointer. And depending on the state here, so I can do is resolved. If it's resolved, then we're gonna return the address of the value, but otherwise we're gonna just return a null pointer, right? So this may lead to the code fail, but at the same time, we basically we allow for doing this null pointer comparison on the get value, right? So we can just check if there is actually a value on the async result. If you think this approach is not good, Let me know in the comments, and yeah, I just think about it and maybe change it, right? Cool. So that's AsyncResult. We're gonna need to add a template specialization for the void type. Probably remember it's not possible to substitute t with the void. This is not gonna work. Compiler is not gonna compile that code. So we're gonna need to add specialization, but not at the moment. Let's just move on with what we have here, and just add this AsyncResult to here, right? And let's think about, is there any other place I need to do that? No, that's for now. This is it. This one is gonna have to be AsyncResult, I think, right? Because what we return in this callback is n, but we would like that to be right. Yeah. So this is gonna be AsyncResult n. So AsyncResult n, and that also has to be AsyncResult n, right? This is a requirement of the given function to the constructor of the future, right? Something like I've done here right now. We have to enforce this. We have to enforce this, and now let's think about how to combine those two futures, because this is not gonna work in that way, right? We need to handle it somehow now. So for that, what I was thinking about is to create a method that I'm going to call poll method. That poll method is gonna take AsyncResult, but of the input, AsyncResult of the input. So I'm just gonna call it input here. And the return type of the poll would be the AsyncResult with the output. So this is really a sort of core functionality of a single future, okay? Because we would like to operate on AsyncResult in the context of future, but for the user, for the consumer of this future API, we don't really want to them, to take this AsyncResult in here, because I mean, that is really an implementation detail that on the argument side, on the input side, this is really an implementation detail if you think about that, right? Because how user of the future is supposed to deal with that, right? We just expect to get an input value here, right? We don't expect to get anything else. However, for the return, we would like to have the control, right? We would like to give the consumer the control over this polling function. So that's why we actually enforce, right, to return the AsyncResult here, right? So this is to tell the future, right, this logic here to handle it accordingly, right? Depending whether we have resolve, that means to move on to the next one, or just stop if there is no next one, or pending means like, call me again, okay? So yeah, so this is the poll, right? Inside the poll, this is where we get the input, okay? So first of all, for the input, we need to make sure that the input is resolved, okay? So if the input is resolved, I mean, maybe if it's not resolved, okay? If it's not resolved, so we get some input and that input is not resolved, then what we would like to do is just return AsyncResult O, because that's the return type, right? And we would like to do pending, because that means it's still pending, right? It is still pending. There is no rejected at the moment, there is no error, so we just consider either pending or resolved, And because it's not resolved, it must be pending, so we also return pending here. The other case means it is resolved. So what we can do is to run our function. We can run our function that takes an input but returns the async result, right? So what we could do is just to do this fn, and the given argument would be the previous result, right? So what we need to do is to do input dot get value, right? We know it is resolved, so there is a value, and we need to deference that, right? Because that returns the pointer, but function takes the actual value, the input, right? The input type. Okay, so that's what we do. This function input value, and we just return that, right? Because the function returns the async result O, and this is the same as the type returned by the poll. Okay, so now the poll can work with chaining, right? This is also sort of chaining. The only thing is we need to somehow call the poll with the input, okay? And this is sort of okay at the beginning if you just have a single future, right? If you have a single future, you can just pass any value there. So let me just show you. Let's say I've just got f1. So if I want to do f1 and poll, the only thing I need to pass here is the async result with the int, okay? This is not very convenient though, right? Passing, like, you know, having to pass async result from something that doesn't exist and, you know, making it resolve. So one option would be to have an overload for the first future, right? So what we can do is, let me show you what I mean. So we'll have something like that, but it doesn't take async result, but just the inputs right away, okay? And if we just pass the input, then we can return this with the input. So this is to handle the first poll, okay? So if we have a first future that takes a value to the poll, right? Like ignore this code for now, just focus on this f1 that takes an int. And if you want to start polling it, right? We want to put this poll, right, on the loop function. We would like continuously call it. It is not very convenient to pass async result. Async result is really for the chaining. I did it for the chaining. I'm gonna show you in a second. But if we want to just, you know, pass a single value, there is this overload, so you can pass whatever you like, right? Cool. You know, you will soon see that this is not gonna be really the case very often, because the first future is usually taking void, so it doesn't take anything. And even when you chain those futures, there might be lots of cases where one future is not very compatible with the second one, or like you have one future that takes void but returns something else, and you have second future that also takes void and, you know, returns something else, and you still would like to chain them. But this is more on the typings, right? This is more to solve on the typings, because this can be solved easily. You could still, like, you know, ignore the input type, for example, and still go on with the second future, right? But at the moment this won't work due to my the way I did and then and everything with the templates. But I add this functionality to cover all these cases later on again, right? So now let's go back to the poll, okay? So this poll allows us to start just polling, you know, on the loop function with the input straight away without having to pass the async result, right? And this poll, this overload, is just allowing the future to pass the input to the input from the previous future when chained, right? So when we have chained futures, this input is gonna be passed. And let me show you how this is done, okay? So we're gonna look at and then where we pass this future, okay? And for that, what we're gonna do what you're gonna have to do is to look at this return value here and, you know, actually return it, because that's gonna change. That's gonna change. What we would like to do now is, you know, taking a function to here is not the best way, because right in here, in end then, you don't want to call this actual function every time the poll happens, like, you know, this top poll, right? The poll on the combined future is called, right? Because this is like, look again, this poll function, this poll callback is gonna be the combined poll, right? And when we call the combined poll, we would like to make sure that the first function on the first future, right? So the fn on let's think about the actual one, right? So in that context, that's gonna be the one with O and output as a async result, output as a output type, and an input I as a input type. And for that one, we don't want to call it when it's not pending anymore, right? So if it's pending, yes, we would like to call it, but when it's not pending, when it's resolved, we want to get the value from it, and that value should be passed to the next one, right? Which is the F2. And then we would like to start calling F2 until, you know, until F2 is resolved, okay? So for that, we need to have some way to read the state, to read the actual state of a single future, right? At the moment, we cannot really do it without calling function on the particular future. And calling the function all the time, every time, regardless of what is the state, whether it's pending or not, is not a good idea, because we don't want to call it anymore once it's resolved. So let me introduce a member, class member here, that is going to be the async result of O. That would be an async result of O, and I'm just gonna call it result for now, right? So that's gonna be result of this actual future at the given point of time, and the default value is gonna be pending, right? So that's the default value. Not sure if this is possible, but we'll see in a second. So the default state, default result of the future is pending, and having that as a public member allows us to read it from here, for example, right? From here, however, as you can see, this cannot be passed. We need to pass this. So I'm gonna call it F1, deference this, and pass this as a first future, right? So that's the first future. The actual one, maybe I just call it this future. Easier. And then this is gonna be next future. So you have this future and next future, right? And this future result is what we would like to check in here, right? So if this future dot result, right, dot is pending, if this is pending, now we need to comply with the return type of this common polling function, and that return type of the common polling function is async result n. So we need to return async result n pending, and that's handled, right? So when this is pending, that's fine, we just return pending. However, if it's not pending, that means is resolved. We would like to get some output, I guess. Isn't it? Yeah, if it's not pending, actually what we could do is just return next future dot, and what we're gonna do is to do poll, right? And on the poll, we're gonna pass this future result. Okay? So that's what we can do. This is what we can do, and maybe we could even simplify this, because if you think about that, if the next future poll gets the pending result, so the input here is pending, not resolved, it's just gonna return the pending. So that code is really duplicated by this code. And in that case, the only thing that we really have to do is not to return the pending, because that duplicates it, but to actually call it. To call the poll on the previous one. Okay? Yes, to call the poll on the previous one. To call the poll on the previous one. The problem with the poll is that the previous poll requires an input, but we've got this input here, right? So I can just pass the input here. Yeah, sorry for the confusion. I'm gonna explain it in a second. Okay, yeah, I'm gonna tell you step by step how this is working, right? So again, I know this is a complicated topic, but try to focus now, and we're gonna start again from the beginning, right? So let's say we have two futures. One future is this one. The second future is this one. And we would like to combine them. And we would like this future logic to first keep calling this one, not this one. This shouldn't be called at that point of time when this one is called, as long as the millis is less, right? Less than time, the actual time in the future, right? So that's gonna just happen continuously. And once this condition is met, right, this result is returned, which is gonna be value times 3. What's gonna happen is that polling function is executed, and that val is gonna be this val times 3. What is val? Let me maybe show you on the example. So you see, this is what I've done here, what I was talking about, right? So I combined f1 with f2, and what I have to do is to do a while, because we don't have a loop function in the native environment. I'm gonna while poll with the input, let's say just is 5, right? Poll 5, hang on, poll 5 is gonna be inside the while. And in the while, we're just gonna check the future result while it's pending, right? So while the whole thing is pending, we're just gonna keep polling 5, right? That's what we're gonna do. Yes, okay. And so this is essentially where everything starts, right? So we've got this thing combined, F1 and F2 combined by this, right? And we're polling the combined future with 5. And now what's gonna happen inside this combined future? So what's gonna happen is, first, it goes to the first future and it checks right here. This is the combined polling function. This is the combined polling function. So as you can see here, we called it with 5, the poll 5, and that's gonna use this overload. So this is calling the actual function, right? The actual function on that combined future, and this is the function. This is that function, right? So what we're getting here is an input, which is 5, right? That's what I passed in here. So we're getting 5. And what it does, it checks this future, this future is F1. It checks the result if it's pending. At the beginning, is the first poll, right? At the beginning, it is pending, right? It is pending because it didn't even do poll yet, right? Bear in mind, the poll we do is the poll on the combined future. So what's gonna happen if if on this future is pending, there was no poll on this future, it is going to do the poll on this future, right? On F1. So we do this future poll on F1 with input, and the F1 future, which is this one, right, is gonna call its polling function, which is this one, with that value of 5, right? So we get 5 in here, right? And then what happens? It checks the millis with the time, because the time is in the future in 2 seconds. This is not gonna execute. This is not gonna execute what is inside the if. Instead, we're gonna return pending. So the pending is returned. Let me show you. So the pending is returned from the poll. And at the moment, yes, we've got an issue here, right? Because this is not gonna go anywhere. At the moment, what happens is that just, calls that function and return it somewhere, right? It's not really what we would like to do. We would like the poll to change the state of the future when it's ready. And then to return it. You see, going step by steps actually helps you to find the issues and missing parts in your code, as we actually had right here, right? And also, this one needs to be changed, isn't it? Yeah, that needs to be changed. So we want to do something like that. This result equals this, and then return this result, just to comply with the return type of the poll. But I will think about this return type at some point, because we may not need to return anything from the poll. That that would be ideal, but let's see if it's possible. It should be possible, but for now let's just keep it like that, right? So so where were we? Where we were on this future, right? This one, returning pending, right? So we return pending. When we return pending, that's what happened, right? We set the pending to the result, and after that one, after this call in here, right, the pending is still the result. So it calls the next future, right? It calls the next future poll, which is F2. That is F2 here. And the poll of the next future, with this future result, right? That's important. So the result is still pending on this future, right? So we call the next future poll with the pending result. And what's happening in here is this overload, right? So on the F2, we get the input that is not resolved yet. It is pending. So what's happening? We just return pending, right? So for the entire combined future, right, we just return pending. Okay, so that is still the result here is still pending. It is still pending. So the result of this whole thing is gonna be pending anyway. Okay, which is really the result of the next future. Right, and what's gonna happen next? We call poll again, right? We call poll again, and that poll is going to call F1 again, right? Because this is still pending, and again, it's gonna return this bit, the next future, this future result, which is pending. So it's gonna go to this one, which is not resolved, and pending again. So we're just gonna keep getting pending and pending and pending all the time, until the millis is greater than the previous millis plus 2000, right? Plus 2 seconds. And when that happens, we return resolve with the value times 3. The value is 5, remember? So it's gonna return 15. And that 15, along with the state, which is gonna be resolved now, is going to be detected in the next future poll, right? Because this code is not gonna happen anymore, right? Once we resolved, this future poll is not gonna be called. And the next future poll is gonna be called with the result that is resolved. And that's gonna happen in here. So we get the input that is resolved. So this what is here is not happening anymore. And instead, we're just getting the result from this function, right? And we give the input value, the get value. So that's the get value from the previous one. That's gonna be our 15. That's gonna be our 15. The return from here, from the F1, which is 15. And that's what we pass to the function on the second future, right? And what happens there? And what happens there? We get it here as a 15. And we resolve immediately with because it's 15, it's gonna be false. So we resolve with false. Because we resolve with false, the result here is gonna be resolved. And that's what we return as the result resolved, right? So that's what happens, what is returned also here. Because we return resolved, that's just, you know, the async result from the next future. And we getting it here. We're really getting it here. We can actually check on the poll. So, you know, I could do fpoll 5 while fpoll 5 is pending. I could do that, right? Instead of just doing, you know, fresult is pending. We could do something like that. And, you know, let's test it. Let's test if this is working. So, yeah, you see. So while this is pending, we can just continue. And once this is finished, I can do std count and just do, I can do poll again, to be honest, because it's not going to change anything. It is resolved already. So I could do get value, but I need to deference it. Hopefully this is going to compile, right? So this while, we can just do that, right? Oh, you know what? Even better. This is better, right? So I don't need to poll anymore. Cool. So yeah, at the moment, you know, this is our executor, right? This ensures that we poll the futures. Okay, let's give it a go then. However, I've just realized this overload on the function. This is not ready yet, so I'm gonna comment it out for now, and we just test it with the futures, and then we add the then overload. Okay. So yeah, let's give it a go. Let's see if it compiles first. So we're gonna do PIO test native, and let's see what errors we're gonna get. There we go. And let's try to fix them. So there is something missing in here, which is the bracket, the closing bracket, right? I think this one is, yeah, that was just in a wrong place. And let's try again. Okay, there is something else. So we've got non-void function does not return a value. Oh yeah, okay, so resolve is not ready. That is pretty straightforward. I just need to do AsyncResult t and just pass the input. So it's gonna use that constructor, right? That constructor that makes it resolved. Okay, one more go. And there is another thing, which is error. This argument to member function is pending, has type const. Oh, I see, right, okay, yeah, this is important. This is important, I forgot to do it. So, because we use the callback function in here, right? To handle that logic, that this future and next future, as a default, they are given as a sort of like a constant objects. So you cannot really mutate their state. And if you want to do that, you need to add a mutable. I'm not sure if it was here or on the other side. Let's see. And once you do mutable, then the copy that you capture with that callback in here, right? So those two copies that I capture, right? I capture this future and next future. And once we have mutable, we can change them, right? So it's gonna keep its state. Let's see if it fixes the issue. It does, right? It does. And now it's running and it's finished. You see, it's finished. And what we got is 2000 milliseconds total, right? So that was the time the whole thing ran for, which is exactly the same time we set for this time variable, right? That we given to here, right? So we were waiting for 2 seconds until that result. Also, we got a 0 here, and that 0 is coming from the get value on here, and that 0 is from the boolean, right? So that's from the boolean. Here that is false, right? 0 is false. So if I change 5 to 6, let's say, I change it to 6, and I increase that time. Let's do 3 seconds. And let's see if we get 3000 milliseconds now, because that's what we should get, and we also should get 1 now. And there we go, right? We've got 1, and we got 3001. So there was 1 millisecond. I guess, you know, this code ran for all the second future, okay? Right. Beautiful. If you are interested in how this really works internally, like if this really is being called continuously, let me show you. So if I do std count, and I'm gonna do it on millis, let's say, we should see a changing time. We should see a changing time. However, it's probably gonna run for more than 3 seconds because all this extra things that needs to be done with the displaying all this data. So you see? Yeah, so now it was slightly more, right? The testing is 3063 though, right? So you see, in 1 millisecond, oh, actually, yeah, that's the value changes slightly in a slightly different way, right? But you see the point, right? So that just displays it on every single iteration when this first future is still pending. Okay. Cool. Nice. Okay, let's do this callback now, because callback is gonna be pretty straightforward. What I mean by callback, what I mean by callback is, what if I want to just, you know, keep the code I had before. So, and then that is gonna be with const char. But I would like to take a function here instead, right? So that would be, that was boolean value. And depending on this value, I would like to return either true or false, right? But in a form of the string, okay? In the form of the string. So let me show you how to do that, because this is just a specific type of future if you pass this callback in there. And let's go there. Let's go to this method, okay? So that method, we're gonna keep this std function and all, right? We take in a function now. We can just call it, can we call it fn? We could call it fn, but this needs to be renamed, I think, because this is not really fn. I mean, fn doesn't really tell us anything. So you know what? Not references, hang on. No, that's not what I wanna do. Change all occurrences, which are, there is lots of them. Yeah, you know, I'm just gonna do it manually. Let me change that to something else. I'm just gonna call it poll function for now. or poll callback maybe. Poll callback is better name. So we'll have something like that. This one I'm gonna keep for now. But yet, is it anywhere else? This is just doing poll. Oh, I think it's there and there. And I think this is it. Nice to have tests so we can verify it. Let's do it. Let's verify it before I write this code for the logic for and then. Yeah, there's something I missed, which is what it is. Oh, this is because I added that. Quick test. Anything else I missed? Oh, okay, yeah, so now actually it found that. Okay, there is the issue. So that's poll callback, right? Equals function. We can just call it callback maybe. And here callback as well. Let's see. Yeah, now, okay, nice. Now that works, right? 3 seconds. Great. Okay, let's focus on the and then, because and then is gonna be pretty straightforward, really. What we could do with and then, if you think about that, is to just run this other overload. So I can do return this and then, and I'm gonna pass n as a generic argument. And then inside, what we would like to pass is the future, right? So I'm just gonna create a new future, and that future is gonna take n and, sorry, that was O and n, right? Remember the output type of this one is the input type of the next one, and n is this output type of the next one. And here we would like to pass this callback, this poll callback, right? And that poll callback, that is important, is taking O as an input. We need to capture this function. Let's just call it fn then, right? It's gonna capture it, and it's going to return async result, and that async result is supposed to be n, right? Which is exactly the same one that we have as a output type of this function, right? So what we could do is to run this function with the input inside here, okay? So pretty straightforward, right? So this one is really calling that one, because as I said, the function is just a specific type of future that resolves immediately, right? So once this is chained, right? And I mean, the previous one is resolved, we would like to do this one, sorry, yeah, this should be resolved, okay? So that's what we want to do, right? So we use this and then, and we pass the future, we pass the new future with the polling callback that takes an O as an input and return async result and resolve with calling that given function in here. This given function, and that given function is to this given function we pass the input, right? Right. So whatever is gonna come from the previous one in a form, you know, of this type, right? The O type, the input, is gonna be passed to that function given to the and then, and whatever that function returns is gonna be set on the async result, right? So the async result is gonna be resolved with. Cool. Right, and let's see if this is working, right? So, oh yeah, I need to do it manually again. So const char and F3, not F3, that would be something like that. So we have boolean and value, and we'd like to return if the value is true, then we return true. If the value is false, we return false, right? Something like that. Great, okay. Yeah, so let's see if this, yeah, we need a semicolon. So let's see if it compiles, Let's see if it compiles, because that should do the job. And with that, we should have our futures completed in the simplest way I was able to do it. There might be simpler way, but you know, I spent lots of time, to be honest with you, couple of weeks to figure out how to build this, and this is the simplest form I could come up with. Cool. Okay, so that works. What we're getting at the end is true. Sorry. So what we're getting at the end is true. And as you can see, this is working. This is working very well. And, you know, no complaint from the compiler. Also 3 seconds. So you know what? We can now write some nice test. Okay. Some nice test, which would be on the functionality of this futures, maybe. That's something we could do for now. Because, you know, I think about the more like specific tests just to test the future logic, which I could sort of do. But for now, yeah, let's just see if those values get passed. So we should have this while and another while for, oh yeah, we're gonna need to create another future, right? So this is F1, F2, so let's call it F. You know what we could do? Let me think about that. Yeah, let's just do auto G equals. I'm not sure if I can do something like that. Probably yes. Probably that's gonna copy it. So we have the copy here. So we have F and G, and F is gonna be on the. Let's do on 2 again, and this is gonna be on 3, right? And after this one, so once the first one is resolved, that's 2. So 2 times 3 is 6. That should give us a true value, true. So we should do asset equal, and that would be F result get value difference though. And that value needs to be true. And on G, we're going to do G result get value true. So you know what? We can actually run both of them. We can actually do even something like this. Or the other one is pending, right? So if this one is pending and the other one is pending, that's just gonna continue. That should be false though, right? Because G is 3 times 3 is 9, and that's false, yeah. So yes, that should be one thing. And another thing would be to check with the millis, right? We would like to check with the millis, so that's gonna be asset equal. And what I would like to do is to check if the millis, the actual millis, is so that should be, that is not gonna be equal. That's gonna be asset greater equal, and that should be millis and the time, right? Time, because millis should be greater or equal to time, right? So these 3 assertions to test that code. You know, I could actually introduce another feature in between that is again in the same, or like maybe, no, that's fine for now. I will try to, like, you know, add some more tests later on off the camera. I can just tell you, so for the future 2, instead of resolving it straight away, I can add something similar, right? Something similar, but maybe not on the millis, but something else, and then try to test that. But for now, this is good enough, I think. And let's see first if this is working, because I'm not sure. Okay, yeah, this is working. This is working. So nice. So that passed. And yeah, I'm gonna do some work now. Unfortunately, off the camera. I mean, you know, if you are interested in my coding sessions, right, where I try to describe step by step what I'm doing even if the topic is very complicated. Let me know in the comments, but I need some time for myself now to organize this. And we're gonna have another video on the futures tomorrow. I will show you how to do error handling, because, you know, resolved is not the only option. We would like also to be able to reject. And I might think about other improvements, or just, you know, maybe try to do them, or just think about them for the future, right, with those futures. And yeah, so that's gonna be it. I think tomorrow is gonna be the last day on that subject, right? Let me know if you enjoy it, if you find this useful, and you are interested in this type of content, you're looking forward to the next videos. Don't forget to subscribe to my channel. The button is somewhere there. So yeah, press on it, click on it, and you should get notifications whenever I upload something. Cool. Thanks for watching, and see you tomorrow.